Am I audible? Is the screen visible to everyone? Let's wait for some minutes to students are less for that. Okay, so I think the students are less, so we can still start the tutorial. All right, so I just write the question number 1 for the tutorial second. Question 1 says that if you are given a vector alpha, which is given to you as 1, 2, 3, gamma as 310, sorry, this is beta, and gamma as 213, delta as -136, then you have to check whether gamma is linear combination of alpha and beta. Wait a second, I just removed this thing. Whether gamma is a linear combination of alpha and beta. So how do you check that? Any guesses? How would you do that? You have to check that gamma is a linear combination of alpha and beta. What do you mean by linear combination? Anyone? Okay. So if so gamma is a linear combination means implies that there exists some, okay, I guess right, there exists k1, k2 such that gamma can be written as k times k1 alpha times k2 beta, right? So this is what gamma is, right? So you have to find what is k1 and what is k2 to find the solution. So just find out. So gamma is what? Gamma is 213. So just substitute the values of the k1 times alpha, which is 1, 2, 3. Just substitute the values. Beta is 310. And what you get? 213 as this. So what you finally get is this k1 plus 3k2 is 2. 2k1 plus k2 is 1. And 3k1 is 3. So it implies that k1 is 1. And from the second equation, it implies that k2 is -1. So from the first equation, lies that -1 plus 3 is what? No, 1 minus 3 is 2, which is not possible. So first equation is violated. Okay, first equation is violated. It implies that. So the another equation is delta is linear combination of alpha and beta. Can you check it once and tell me is it correct or not? If everybody understand this first part, and if
Yes, sir.
everyone, yeah. So it's very easy. Just check the second part if it's true. In the sense, can you do that? I think you can do the same approach and you can find out the solution. Is it very clear? Okay. So if there is any problem in this, just let me know. or similar type of things. You should understand what does linear combination means, and you already done the questions on the basis, dimension, and all. Then I move to next question. Just do the second part for some time. Okay, I just write another question for all of you. Is okay, I just write another. Wait a second. Question 2 is which of the polynomials lie in the linear span of s 1 plus x square comma 1. Okay, then which of the polynomials lie? So first one is x square plus 1. Second one is x square plus x plus 1 plus 2. Third one is, so similarly, I don't write much, whatever. So you just check which of the polynomials lie in the span of this. Okay? Can you do that? And tell me which of the polynomials lie? Span means, so span means linear combination. Okay? Just let me know. Try this question. I have not given the same questions as in your, I think in your assignment, same options, but you can approach in the same way. Okay, we can try that. So let's start with x squared plus 1. Suppose x squared plus 1 lie in the linear as in the span, then it can be written as for some a, this happens, right? And for some b, this happens. Then what you get? A plus ax square plus b, right? Then you get a plus b plus ax square. That it implies that a plus b is 1, a is 1, yes, and a is 0 because coefficient of x is 0. So it's a contradiction. A is 0 and a is 1. How is it possible, right? So first one is wrong. Is it clear? Okay.
Yes, sir.
And for the second one, can you do that?
Yes, sir.
Okay. I think it's very similar and it's very clear. So, um, so you don't have any problem in solving the questions in your assignments based on that. Next question I want to have is, okay, we have another question in our hand. This is question number 3. So let V be a vector space of functions. So let capital V is consist of functions f such that f is from R to R. Okay, then you have to check whether ft is equal to sin square x, gt is equal to cos square x, ht is equal to cos 2x are linearly dependent or not. Can you check and tell me is it right or not? Yes. Let's take here cos x, not cos 2x. Okay. Just tell me and check whether it's linearly dependent or not. What is the approach? Anyone? What if they are linearly dependent? What is the condition? Anyone? Just tell me. Harshita, you want to tell me?
So linear dependent means a set of vectors or matrices has at least one linear
Hmm.
combination of element that equal to 0.
Yes, yes. Okay. Let's try with that. You're right. So, since suppose F, G, H are linearly dependent. Okay, linearly dependent. Then what happens? Then there exists A, B, C in R such that AF plus BG plus CH is 0. Am I right? This happens. Okay, then what is the next step? Anyone? So I just write A sin square x plus B cos square x plus C cos x equals to G. Yes, what is the next step? How do you prove that they are not linearly dependent, or if they are, then what is the next step? Harshita, yes. Any other person?
Differentiating with respect to x and equation.
Differentiating, okay, Minakshi. Differentiating with respect to x. Is that the only solution, or you can just substitute something? Because it happens for every x in R. So what you can do is you just substitute. Let x is equal to 0. Then it happens. What is sine 0? That is 0. Cos 0 is 1. And cos 0 is again 1. So that is 0. So b plus c is 0. Okay. This is the equation you get. You need 3 equations. Okay. So let x is equal to pi by 2, because these are very convenient. So sine pi by 2 is 1, cos pi by 2 is 0, and cos pi by 2 is 0. So it's 0. So a is 0. And similarly, because there are 3 variables, you need 3 equations. So x is pi by 4. Then in that case, you have a by 2, because sine pi by 2 is root 2, and b by 2 plus c by root 2 is 0. So since a is 0, so b plus c root, sorry, b plus root 2c is 0. and b plus c is 0. So what you got? B is minus root 2c and b is minus c. It means that minus c is minus root 2c. It implies that c is non-zero, so minus 1. So 1 is root 2, which is not possible, right? This is a contradiction. Okay? So there does not exist ABC such that AF plus BG plus CH is 0. Of course, non-zero. Is it very clear, everyone? Meenakshi, Harshita, everyone?
Yes, sir. So they
Okay.
are not linearly dependent.
Yes. So they are not. Any doubts? You were asking something, Harshita, I think, or you is it clear?
No, sir, clear.
Okay. Okay. So let me write another question for you. Wait. Let's see. Okay. So you have a vector space V, okay, and set V1, V2 up to Vn is spaces of V. Then set V1, V2, Vn. Okay. Is linearly dependent. You know what is basis, everyone? I recalled the last time, right? So what is a basis? What is a basis of a vector space? Meenakshi, you want to tell the definition of basis?
Linearly independent set which spans the vector space.
Yes. It can be finite or infinite, depends. Okay. So here it's finite. So it's very easy to check whether it's linearly dependent or independent. So once again, we do the same thing here as well. So what you say, suppose, so let's say suppose S is linearly dependent. Okay. Then there exist AIs. I varies from 1 to n plus 1 such that a summation ai vi I equal 1 to n plus 1 is 0, right? Then what is the next step? What is the next step? Because v1 v2 vn are elements of the basis, so there exists something which is 0. So what I would do is try to change, say I equal 1 to n ai vi equal to minus an plus 1 vn plus 1. How will you prove that? Any idea? Just take some time and to prove. Just take a couple of minutes. Try to prove it. Yes, how will you prove it? Any guesses? Everyone. Harshita, Meenakshi, anyone? Any idea to prove? Okay. So if an plus 1 is 0, we have a condition, then summation I equal 1 to n ai vi is 0, right? This implies that ai is 0 for all I, right? So because why this is 0? Why this happens from this to this? Anyone? If summation ai vi is 0, then why ais are 0? What's the reason behind it?
Like are elements of basis.
Yes, yes, you're right. And but if an plus 1 is non-zero, then vn plus 1 is belongs to span v1, v2 up to vn. But what does this implies? Then the SAT, this implies the SAT v1, v2 up to vn plus 1 is linearly dependent. Yeah, I think so. Ultimately, this vn plus 1 is lying in the span, so this SAT should be linearly dependent. That should be a proof for that. Yeah. So you know the basis is basically the smallest linearly independent set, means it's the smallest subset of a vector space which is linearly independent. If you add any other vector, then it becomes linearly dependent. But if you want to be, but it will span, of course, it will span the vector space if you add any other vector in it. But if you reduce some vector, then that set will also be linearly independent, but not, it doesn't reach to the dimension of the basis. So you need a basis, which basis means linearly independent set which spans a vector space. Okay, so it's true. So similarly we have other question. Okay, may I write that? Question number 4, let S is equal to 110 and 213 contained in R3, then which of following is not in span? Then check A. Check which is not in span S. So first one is 000. Second one is 111. Yes, just check are they in span S or not. Okay. Just check. Yes. Have you checked it?
Sir,
I think.
Yes.
Yes.
Which are the correct ones?
So
A is
B.
correct.
मतलब not
B.
कुछ.
Not a
B.
span, but B is not a span.
B. Yes.
B is not in the span and A is in the span.
Yes, sir.
How?
It can be written.
Okay, I believe you. Is 0 always in the span? Let's see. Okay. 0 may not always be in the span. Okay. But in the case of but vector space is what we say vector space, it is a abelian group under addition, right? But span S, if you consider span S, then it's a vector space. Then 0 must be in span S. Always. No matter what the S is. It is always in the spanning set. Is it clear?
Yes, sir.
So we have another question. We have direct test question. So let U1 is your this space xy 0 in R3 such that xy is in R and U2 is this one 0 wz. Then you have to prove, okay, then you have to check whether, okay, so what I would say, you have to find, okay, dimension of U1 direct sum U2. You know what is a direct sum means? What is a sum? What is U1 plus U2 mean? Z1 plus Z2 such that Z1 belongs to U1 and Z2 belongs to U2. Okay. And what is the direct sum means? It means that U1 intersection U2 has to be, what we say, has to be phi. And what is this? Okay. Can you find the dimension and tell me what is the dimension? Everyone. U1 is the subset of R3, U2 is the subset of R3. And there is a result which says that if dimension of S, if dimension of W, sorry, if W is a subspace of V and it happens for finite dimensional cases, dimension W is dimension V, then W is V. Okay, That's clear. This is a theorem. I'm not proving it. But you have to find the dimension of this. Tell me, what is the dimension? It's very straightforward. Here is an element which is common. Sorry. Here there is one element. Sorry, it is 0 actually. Yes, tell me. Shafa, what's your name?
Sir, it's Shafak.
Shafak, yes, tell me. What's the dimension?
Sir, 3.
Why?
Sir,
What,
cause
why?
0 will be x and y plus w will be y plus w and 0 plus z will be z. So I think
Hmm, wait. What is the dimension of U1? What is the dimension of U1?
2.
2.
So dimension of V1 plus V2 equal to 4.
Yes, yes. And what is the dimension? Oh, U1 intersection U2 is not 0, right? What is U1 intersection U2? Tell me. What is U1 intersection U2? Wait, I just check. Okay, so but why they write the direct sum? This is, I don't know why it's that. It's not a direct sum, right? Why it's a direct sum? Is it a direct sum, everyone? What is U1 plus U? What is
Yes.
U1 intersection U2? Is it 0
Why?
or not?
So 0.
Why? Anyone? It's not 0. Why you are saying it's 0? Check again. What are the elements in U1 intersection U2? Just tell me. Look again, see again things. Then I will tell you. So we use this. So U1 intersection U2 is not 0. So there will be just plus. Okay. And U1 intersection U2 has the elements this 0, say S comma 0, where S is in R. Is
Okay,
it
got
clear?
it, sir.
You got
Yes,
it?
sir.
Yeah.
Yeah.
Okay. Just check from this. So what is the dimension? Now, what is the formula you will use? I have told you before this formula. Tell me, how do you find the dimension now?
W1 plus dimension of W2 and dimension of W1 intersection W2.
Yes. So what is the dimension? Finally, you get 2 plus 2 minus 1, which is 3.
3.
So what does it imply by this theorem? Everyone. What does this imply? What is U1 plus U2 basically? What this space is?
R3.
R3.
Yes, because R3 has dimension 3 and it is the subspace of R3. Is it very clear?
Yes, sir.
Okay. So we have another question again. Let me write it. So you have this question is, so you have two planes x minus y plus z equals 0. First one. Second one is x plus 2y minus z is equal to 0. Of course, they are in R3. Then you have to tell me. So m, this is given by m and this is given by n. Then R3 can be written as m plus n. Can you check it and tell me, please? So what the elements of M look like? M is x, y, z such that x minus y plus z is equal to 0. N is x, y, z such that x plus 2y minus z is equal to 0. Right? So what's the dimension of M? Can anyone tell me?
There's
And what's
2.
the dimension of N? Why it's 2?
Sir, we will minus one restriction from it.
Yes.
Y x minus y plus z is a
Yes.
restriction.
Yes. So 3 minus 1 is 2. 3 minus 1 is 2. And what is M intersection N? What is M intersection N?
Sir, its dimension will be 1.
No, I'm asking about what is M intersection N. What is this space?
X, y,
Exact.
z, x minus y plus z will be 0 and x plus 2y minus z
Yes.
will be 0.
So it is x, y, z such that x minus y plus z is 0 and x plus 2y minus z is 0. So you have two restrictions. So dimension will be 1. 3 minus 2, which is 1. So what is dimension of M plus N? Yes, tell me. That is 3. And which is same as R3. Okay. So it's correct that R3 is this direct sum or not? Is this a direct sum or simple sum?
No.
No, because M
Simple
intersection
no.
N is not 0. Sorry, it's not 0. Is it clear? Okay, let me write another question for you as well. Consider the subspaces and then you take some minutes to solve and tell me. Subspace U and W of V equal R3, then U union W, then if U is xy0 such that xy in R, W is x0z such that xz in R, A, B, U is x0z, xz is in R, W is 0yz, yz is in R. Which of the following? Then if this happens, then U union W is a subspace. Check in both the cases, okay? Just take 5 minutes, check in both the cases, with which conditions it's true. Yes, tell me. Is U to union W a subspace or not? What is true?
No, sir.
Why? So you have a result which says that U union W is subspace of a vector space V if and only if U is contained in W or W is contained in U. Is that clear? So you can use that result and get the answer. Right. There is another question that has. So we do have to search for another questions. Wait for a couple of minutes. Just check. So it's the question for you guys. Check the vectors 1021, 2011, 101 minus 1 contained in Q4 are linearly independent or not. I just write some questions, then you have to try them. These are different questions, okay? Just start typing. Just start to try. I will ask after some minutes. I will write 4 to 5 questions. Okay, next question is find a basis of vector space V is equal to x minus y, 3y, 2y minus x, 2x, such that xy is in R. Next is if E1, E2, E3 is a basis of a vector space, then is 2E1 plus 2E1, 3E1 plus E3, 6E1 plus 3E2 plus E3 is a basis of V. Next is okay, just try these questions for some couple of minutes and we will discuss. If you have any problems, we will go with another questions. Right. Yes, have you done that? Everyone? Tell me the
Yes, sir.
solutions. First one is linearly. What is your approach and how would you solve that? I'm not asking for solution. What is your approach? Is it linearly independent? First question. Shafaq?
Yes, sir.
Yes. How will you do that? The same way. You just consider some elements which says that their linear combination is zero. You try to find out those vector, whatever, those scalars, sorry. So you ultimately reduce to a system of equations or a matrix to solve it, right? Am I right? You convert into a matrix.
Yes, sir.
Yes. Then you find out. So the main thing is to give this question is to find out is, yeah, using the matrix, right? So that's it. For the second question, what is the basis? Tell me. What is the basis of the vector space? Have you tried?
Yes, sir.
Yes.
1 0 minus 1 2 and minus 1 3 2 0.
1 0 minus 1 2 minus 1 3 2 0. Is it right?
Yes, sir.
Everyone is getting the same?
Yes, sir.
Okay. Okay. And what about the third question? E1, E2, E3 is the basis, then? Is it the basis? How will you check it? Everyone.
By matrix approach.
Yes. So the answer is using matrix approach. Yeah, I just write some more questions so that you can practice again. Okay. Let me write that. Yes, so find the dimension of vector space in P3x. So sorry, in P3x, right? So S is given by ax cube plus bx square. So what's the dimension of this? Okay, tell me. I will write question and you will tell me what's the dimension. Anyone? What's the dimension of S? Can anybody answer it? It's very easy. Meenakshi, Harshit. Yes. Shafaq, Meenakshi, Harshita, anyone?
So 2.
Why 2? 2 is not correct.
Sir, 4.
No. Other than that, okay. So
So
dimension,
3.
what is the dimension of P3x? What is P3x? Is set of polynomials, only this, such that A, B, C is in R. Okay. So this is a set of polynomials which are like this. That is P3x, right? So what's the dimension of P3x? Anybody?
Four.
Tell me. Yes, it's 4.
Oh.
So what is the basis? Tell me. What is the basis of P3x? Yes.
1x x square x cube.
1x x square x cube. Right. So dimension is 4. But what is the dimension of S then? Can you see it? Tell me now. There is one more condition over this. So what's the dimension? Think and tell.
3.
Yes, 3. Why is that? Okay. So we have dimension of S is 3. Because there is one extra condition. That's why. Is it clear?
Yes, sir.
So what is the dimension of P and X? What is the dimension of P and X?
N plus 1. N plus 1.
Yes, so it is n plus 1. Okay, and we have another question. We don't have other questions, I think, now. Okay, if you have any doubts, you can ask. I'm here for some more minutes. 15 minutes. Let me just. So I've tried to cover the things here. Everything.
Hello.
Yes, Harshita, yes.
Yes, ma'am.
Just try all the questions. From my side, the tutorial is over. If you want to go, then you can go, but I have to wait for some more time. If you have any questions, you can stay here. regarding what I've taught today. That's all about linear combination, basis, dimension, all possible questions.